Okay, welcome back. So the final topic for today's or this lesson is going to be iteration. In C++, iterative statements are going to be C++ or any programming language for that matter are going to be used to repeatedly do something several times or until a specified condition is met. We'll be able to use while statements, do while statements, for statements, and we'll get into recursion later if you like to consider that as a way of iteration perhaps. So the while statement. This is going to allow us to repeatedly execute a statement as long as some sort of condition is true. A lot of times what we're going to use the while statement for is that when we're going to execute something for an unspecified or unknown number of times, and we're going to continue to do so until we arrive at some sort of condition. I took the following example from Peter Gosling's textbook, I believe Discovering Modern C++. It's over on my table. Essentially, I wanted some sort of like halfway interesting example for this, and he essentially used the Collatz series in the book. And essentially what this attempts to show is that there's a pathway to the integer value of 1 for every number. So in this case, the while statement that we're interested in, it's right here. And essentially, we're going to continue executing what is in the body of the while statement. So that block will be continually executed until we arrive at the condition that x is equal to 1. So while x is not equal to 1, continue to do whatever falls within this compound statement. A few things to notice here is that we have to move towards that condition. This will turn into an infinite loop or a loop that runs forever if we do not move towards this case. There are conditions where we might want to continue doing something forever with the idea that there are other ways to break out of the loop once we arrive at a condition. And we'll get into some of those loop control mechanisms here in a second. Now, the do while statements is the next one I'm going to introduce. The example here, I guess, is a little bit boring compared to the last, but the do while statement is going to be similar to the while statement, except that it's guaranteed to execute at least one time. And the reason for that is the condition is checked after the block has ran at least once and not before it has ran. So you can see here, it's saying do while that condition, and we're not checking that condition till we've ran through the block once. So what's this little code snippet doing? So there's some variable here, x, it's initialized with -1. And then it looks like I'm writing something to standard output. stdcn allows us to take input from the keyboard in the terminal window. And I'm essentially just expecting the user to type in an integer value. I'm not doing any sort of error checking on whether or not I am actually getting an error or getting an integer value. So if you type in a character, you'll see some funky things happening, but we'll get into how to resolve that and how to do better validation of input values into our programs when we talk about streams. But until now, I'm just assuming that, okay, the user is going to input an integer. Now I'm going to keep prompting them for an integer until I receive a positive one. So that's that while condition here. This is guaranteed to execute once. So the user sees my prompt, gives them the opportunity to enter the value, and then I just cycle back through and continue doing this until I have a value that causes this to evaluate to false. So while x is less than or equal to 0, I'm going to keep executing that block until it goes false. Now, the final iterative statement we'll talk about here is going to be the for statement. The for statement is very similar to the while statement, except that the management of the control variable is going to be at top. And a lot of times when we're going to preference the for statement over the while statement is when we know how many times we would like to execute some block of code. So that's known up front. We're not kind of walking through and waiting until some other condition is arrived at. We know this needs to be done X number of times, so I'm going to execute it as such. So having this kind of control information up top makes the loop very easy to read and understand. The header for the for statement is going to have three components. One is going to be an initialization of the control variable. Another, and that's going to be kind of governing the looping process or the counting towards some sort of end. Continuation criterion, aka the condition, and then some sort of step operation to increment, often used to increment the control variable and move it towards the I guess termination, the converse of the continuation criterion. So here's a simple example that squares the numbers 1 through 10 inclusive, writing each number in its squared value to standard output. So in this case, here is going to be my initialization of the control variable. I'm saying I is equal to 1. Here is going to be my continuation criteria. So I'm going to execute this block of code while I is essentially less than or equal to 10. And then once I hit 11, I'll end. And then the step operation here is going to essentially increment I to move it towards that term, to essentially have this terminate. So how does this work? We're going to execute the for statements header first. So we'll go ahead and initialize I to equal to 1. This gets ran exactly once. So once we've initialized I, we're not coming back and initializing it further times. Next, we're going to compare I against the conditional. If that evaluates to true, we're going to go jump into the loop body and execute whatever statements are in that block of code. Once we are at the end of that block, we come up here and we're going to go ahead and implement, hit this part of the for header, which is going to increment I by 1. We will then compare the incremented value of I against our condition. And if that condition is still evaluating to true, we'll continue this process over. So we'd go back into the body, execute the code here, increment I by 1, check the condition, and we'd continue to do this for the values of 1 through 10 inclusive. So we execute the body starting with I at 1, increment I by 1 after the execution of the body until we reach 10. The control variable I is going to be initialized to 1. We check the condition. If it evaluates to true, hit the loop body, otherwise the loop terminates. If we hit the loop body, increment I by 1, repeat from step 2. So the for statement, just a little bit more information about it. Variables declared in the initialization component of the for header are only visible within the loops body. That means we couldn't do something like cout I here. That's not going to work because I is only in scope within that block of the for statement and within the for statements header. The continuation criteria can really be any sort of expression that's readily convertible to a Boolean expression. The control variable can be modified in the loop's body. So you could do something like here, but don't do that either. Those reading a for statement may reasonably assume that the control variable is only incremented in the for statement header. And if you start doing, increments throughout the body, especially if this block of code that's constituting the loop's body is relatively long, it may not be clear that we're essentially incrementing I multiple times, because again, this is guaranteed to always run. So if we were to add, say, increment I by 1 elsewhere in the code, it would then be incremented again before we hit the conditional. So just, play it safe, only mess around with the control variable in the for statements header.